G'day, Cecilia. I got the stream going, so you're on the stream right now. But I can turn your video off because I just only need to hear you. Yeah, that's cool. You can have the video on or off. It's up to you. But you'll be on my screen. You don't want to be on the stream, right? So you presumably can see that happening. I'm not gonna. I can get it up on my screen as well if I want, I suppose. But you can see those though, right? You're looking at the Twitch stream and the YouTube stream. Cool. So you're on the Software Tech pages. Is the stream coming through? Nice. Now I can hear myself coming back at myself. All right. I should just get something else up. Let's do this. I will have a quick, oh no, restream. So this is the restream chat that supposedly does all of the chats. I might just keep that open, keep an eye on things, but I'm not going to be trying to respond to everything. And it's telling me I got 125 viewers. That sounds about right. And someone's posting pictures of heads. Okay. Probably not. See how different the chats are once we get on Twitch? But it's not a lecture, so you'll have to use your judgment about what to just turf and not turf. I'm not the biggest fan of this just spamming pictures thing. So I'll have a quick chat to everyone about how to use the chat, and then that'll set the rules that you might want to try and follow. No, you're not meant to be out of here, Cecilia. That's just for me. She's my moderator. She's going to tell me if you guys say anything that I need to respond to. I can see the chat right now because I haven't started talking yet. But once I get talking, there's no way I'm going to be able to follow along with all that. So time-wise, it is whatever it is. Basically, it's not a lecture, so it's not set for it's not scheduled. We just happen to be doing it at the same time as the lectures are on because that seems like a nice slot. And it's just a chat about condition stuff. Yeah, the chats are linked, I think. So I linked them, but I don't know if Restream is successfully sending messages between each one. You'll be able to see that yourself. Recorded? No, this is not hooked up to Echo 360 or anything like that. This is not a lecture, but YouTube has been set to keep the stream. Fingers crossed that setting still works. In which case, you'll be able to go back to the YouTube. That's right. Yeah, Mitch, no more lectures for Comp 1000. Just these things, which are officially software technology streams. Twitch does the video on demand as well, but only for 14 days, and we might want to hang on to them for a bit longer than that. All right, I'll talk about administrative Comp 1000 stuff somewhere else. If you want to ask those questions, jump on the forums of Comp 1000, because this, like I said, is not a Comp 1000 lecture. This is a just software technology discussion to do with the stuff that's on the page that just happens to be exactly the stuff you want to know for Comp 1000 at the moment. So I won't cover administrative stuff because all of that I should cover in official channels. All right, so as far as using the chat, it seems to have settled down a bit. This is the kind of thing I'm looking for. I want you guys to be free and open to use this chat in the way you would like to use this chat. But I'm an old man and I don't understand internet culture, and so I'm going to be very conservative about what is okay and not okay. I have no idea what that head was you just put up and what 15 of those heads mean, In which case, things like that, I might ask the moderator just to turf, just to be on the safe side. So normal rules that you might be on any other public forum. Plus, if you find some, completely innocuous internet Twitch streaming thing that you do disappearing, it's just because we don't get it, and we're trying to keep things on the safe side. So Cecilia's got a better idea of these things than me. I'm pretty sure a picture of Bob Ross and the words Bob Ross are okay, but if you put 50 Bob Rosses, that doesn't bring anything to the discussion, so we can just turf it. All right. And so mostly this chat, I guess, is amongst yourselves, but questions, well, it's towards me, but I can't keep an eye on it. And that's what Cecilia's job is for now. We'll see if we can see how this thing settles down. We've never done it before. 158 of you, I think that's pretty good. That's a nice turnout of people who are interested in hearing stuff beyond just reading the text online. You can start by telling me if there's anything you want to know about Booleans, because this is another one that this is another discussion of Booleans, which is a bit redundant in a sense. So we can talk about what we want. Nice and quiet. Okay. Well, the things I wanted to talk about on conditions was, what did I write down? Oh, that's right. We got some built-in variables that are Booleans that we haven't discussed yet. Is there any reason that a Boolean is superior to a char? Well, yes, there are definitely Boolean reasons why Boolean is superior to a char. For one thing, a character is representing a character, and a Boolean is representing a true-false value. So anytime a programmer sees char in your program, they think there's going to be a character in there. They don't think you're going to use it to make decisions. Every time they see a Boolean in there, they know you're using that to make a binary decision, yes or no. The next advantage is a Boolean can only hold true or false, whereas a character can hold anything at all. You might want to put a T or an F in there to represent true and false, but then there could be a P in there. What on earth do you do with that? So you use the right tool for the right job is the short answer. And for the job of making decisions between yes and no, a Boolean is the right tool for the right job. Okay. Well, the difference between else and else if is that else if is just like an else and an if jammed together. Maybe I'll see if I can come up with an example to show that. But it's just a shortening of the longer version. Stream's going to go for however long they can usefully go for. I'm just here to chat about conditions, as long as people want to hear me talk about conditions. And then sometime next week I'll talk about loops. That's the next one, right? For as long as people want to hear me talk about loops. Forever. All right. I could probably do that, Okay. Let's deal with... so I'll hit these two built-in Booleans I want to talk about and see if anything comes up that can tie into those other questions. So that's an administrative thing, alien Tourex, that will be dealt with in the Comp 1000 material, because this is not Comp 1000 material. This is just a friendly chat that happens to be related to Comp 1000 that Comp 1000 students are definitely going to be interested in. All right, these built-in Booleans, the two I wanted to talk about are mouse pressed and key pressed. So I'm going to start off by showing you a quick program that uses mouse pressed and key pressed. I might bump this up a little because I'm on a high DPI screen here. Not too much. I don't need to look completely spaz. And please excuse any noises in the background. Got children hanging around doing homeschooling. It's all fun over here. Now I have to make quite big sizes on this computer, I think, because as I said, I got a high DPI screen. Let's see how that goes. black and white, and my old classic of just running a lecture, just running an ellipse somewhere. You must get sick of watching me write this, but if I put a template in and didn't write it, I think that would be more confusing. Need bigger and bigger this time, and off we go. What happens? There it is, there's my ellipse. So I'm going to hook something up to the key pressed event. So we've spoken about events before. And with events, they happen in another algorithm down here. So anytime a key is pressed, this little bit of code will get run. And what I want to have run in here is, what I'm going to do is I'm going to change the shade of the circle. So I better, if anything's going to change while the program runs, needs a variable. So I'm going to make one. It'll just be the shade of white that I'm going with. It'll start off at 255. And we'll use that in here instead of the set number. And I'll just reduce it every time a key is pressed. So now if I run that, nothing's happening. Did I do something wrong? I'm pressing keys and the shade's just going down very slowly. Okay, I'm going to make that shade go down faster. That might be a bit more obvious. There we go. So I assume you can hear me pressing my key, so you can see that the shade's going down as I do that. The other thing to say is that if I press and hold, remember we get that behavior where it delays for a second before it starts again. Whoa, look what happens when you go into negative shades. It starts going yellow. So that's one way to do a key pressed event. Minus minus is short for -1. I'm going to make that a little bigger, a lot bigger. So I wanted to bring in these two variables that actually have the same name as, well, one variable's got the same name as key pressed, but is not the key pressed event. There's a key pressed event, which is this one here. There's also a key pressed variable. And I can put that out here. So this variable is going to hold a Boolean, I think, true or false, depending on whether a key's being pressed. And because that's going out on the console, I'll be able to see it. And you can see right now it's just false. Every time the draw algorithm is run, it's a false. And if I hit a key, it went to true. And it's true whenever I'm holding down the key, and then it's false whenever the key comes back up. So if I just press it once, it actually went true, but you couldn't see it there. It's whipped past too fast. So there's two different things that act like key pressed. The important thing, or the interesting thing, is this one's a Boolean. You saw it was being printed out as a true and a false. So I can use that anywhere I use a Boolean, and I can use that for conditions. So what I'm going to do now is, instead of having an event that happens when the key's pressed, I'm going to have two paths in my code. One path that happens when the key is not pressed, and one path that happens when the key is pressed. And remember that a draw algorithm runs over and over and over and over again, and it runs the full algorithm, but if the algorithm's got more than one path, it'll only pick one of those paths on any particular draw algorithm, depending on the Boolean. So how about I change the stroke anytime the key is pressed? So what I'll do is I'll say, up here we're doing the fill to be a shade, and I'm going to set the stroke to some crazy shade of green. But that line of code should only run if the key's pressed. So now we have a draw loop that's actually kind of like, draw algorithm, that's kind of like two draw algorithms. One draw algorithm that does go into the key press line, into line 12, and one draw algorithm that doesn't go into line 12. And they're controlled by what's inside that variable key pressed, which is just a Boolean. So as soon as I held down my key, it went to green, and when I let my key up, it stayed green. And that's because I forgot that once I set the stroke to green, it'll stay that way for the next draw algorithm. So I really want my two paths to be no stroke. So on one path I set the stroke to green, and the other path I set to 0 stroke at all. Now I should see when I'm holding down the key there's a stroke, and when I let it up it's gone. When I'm holding down and let it up it's gone. So there's two different paths, two different things that might get drawn, and I don't need this anymore. I just put that in there to make sure we didn't confuse the two key prests. There's two different paths that might get drawn depending on the state of the key. And I might just bump the stroke width too to make that easier to see. Is it stroke width or stroke weight? Always get that wrong. Doesn't like either of them. That's better. 5. Okay. So now my key is controlling something, and I notice something. I don't have to worry about the repeating behavior here as well, because this Boolean is just an on-off. True, false, depending on whether a key, any key, is down. So there's another one of these for mouse pressed as well that I can use. These are built-in Boolean variables that I can use to split the execution of my code. So I had a question about the else if. So maybe we'll try and explore that a bit using the mouse pressed variable. There is a built-in that records which specific key was pressed, yes. It's the same one you would have used in the key pressed event, which is just, I think, key. It tells you the key that was last pressed. It's always storing the key that was last pressed. So let's play with the mouse clicked as well. With the mouse pressed, I always forget exactly the name of the variable. Let's leave this key pressed one to fiddle with the stroke. Let's make the mouse pressed change the position that we're drawing the circle at. So I'm going to have to store the position if I'm doing that. Anything that has to change needs to be stored. And I'll start them out at width divided by 2, height divided by 2. Okay. And so now I set the X and the Y over here instead of hard coding them. So this is all standard stuff we learned in the variables topic. So if you're struggling with this, go back and reread that. But what by putting it in a variable lets me do is it lets me control it with the mouse press. So let's do it in two different ways. There's a mouse pressed event, if you recall, where anytime a mouse is pressed, or I think I want clicked, which goes for the down and the up, the pressed goes for just down, then I will look up the built-in variables for mouse X and mouse Y and set them to my X and Y. And then the next time the draw algorithm runs, that should draw the thing in a separate spot. So there's still only two paths in the draw algorithm, but there are many, many more variants of what the draw algorithm might do because it's relying on that underlying variable. There's 800 by 800 different possible things it might do because it's 800 by 800 different possible... Yeah. Okay, different possible things. Back in a sec. Yep, that's the way it goes. Apologies, but he's too cute to get angry at. Okay. Mouse X, mouse Y. Off we go. Let's run this program. Okay, so now hopefully when I click, yep, the X and Y position are updated and it moves to that new spot. So I was going to show you how to do this with the mouse pressed variable instead. Let's just bring up that. Okay, so you can see in the reference here that there are the events, they're the ones with the parentheses after them, but there are also, for a lot of them, the variables to go with it. So down here was the key pressed event, and here's the key pressed variable. And so there's a mouse, we just use mouse clicked. There's no mouse clicked variable because it doesn't really make sense. Mouses are clicked at an instant in time. They're not clicked and, but there is a mouse pressed and a mouse released. Sorry, a mouse pressed to say that currently a mouse is being pressed. So I'm going to use that up here. So let's make a whole new if. So what do I want to do on a mouse press this time? Well, why don't I still update the position of the X and Y? Now let's do something different. Let's make it move down the screen. So as long as the mouse is pressed, Y will equal Y plus 1. So now this is not something that happens once. This is another branch in my draw algorithm. So now my draw algorithm has, there's 2 possible paths at the top, and then again there's 2 possible paths further down. So we do the combinations, there's 4 possible paths. It can go into the key pressed and into the mouse pressed. It can do the else on the key pressed or on the mouse pressed, so on and so forth. And let's say that if the mouse isn't down, then we will do Y equals Y minus 1. So as long as I'm not holding the mouse, it's going up. When I am, it's going down. There we go. And so there's not an event happening here. It's not happening just once on the click. It's just a variable in the background that processing's keeping track of, that's a Boolean, that's true sometimes and false other times, and I can use it. I want you to note that there are, like I said, 4 paths through the algorithm this time, right? Unless my combinatorics are wrong. Good. So lots of different choices. Now we're going to fiddle this to use an else if instead, just to give you an idea of what the difference is. So with this one, when I press a key, when I hold down a key, we get the green, and when I hold down the mouse, we're going down. So I can tell exactly what I'm doing by doing it. Let's try switching this guy from an if to an else if and see what happens. So first of all, it complains because you can't do if, else, else if. You can only ever do if, else if, else if, else if. Because what really an if, else is doing is it's shortening the situation that looks like this. It's shortening one of these where you had an if and then an if, one after each other, with an else at the bottom. It lets you put an else if in here instead. So why on earth would you ever want to do that? Well, I think it's more complicated. Some people want to do it because this is a really nice flow for a programmer to understand. There's only 3 paths in this code and you can see exactly the 3 paths. Whereas when you've got if and then a something and then an if, there might be 2 paths, 3 paths, 4 paths. You've got to follow it more carefully to work out exactly how many paths. But the if, else combination shows you clearly exactly how many paths. But it is more restrictive. There's less things you can do. Like we couldn't do the thing we just did then. Okay, so that's my little discussion of if and else. An else if. And showing off the key pressed and the mouse pressed. So is there any questions that have come up from that? Simon stuff, save that for the Comp 1000 forums. What's better, if or else, or just else? It entirely depends on the situation and the coding culture you're in. I don't use else ifs very often, but that's just from that's because of my programming background. If you're choosing between a set of mutually exclusive possibilities, then I'd say else if is better. But only if they're mutually exclusive. And that doesn't happen a lot. Well, that happens a lot. But in programming, we're very often dealing with situations that aren't mutually exclusive. We're very often dealing with combinatorial blowups, because that's exactly the situation in which a computer is helpful. Can I show you true and false variables with key pressed? Well, key pressed is true and false. So I'm not sure what you mean. Okay, just what about Booleans? Where am I going? Hit me with one of them, I'll go over it. So a more general question on Boolean, you're saying? I need something slightly more specific. They're talking about assignments. That's not useful. All right. Yeah, that's right. So Bart Bengal, that's right. Yeah, if else format allows only one of those options to be used. Yeah, whereas in the other one, we could go down either of the first two paths and then either of the second two paths. So it really all determines based on what your program needs. But one thing to know is that you can always do a similar thing without having to worry about else if. You could make one just not so obvious that it only goes down three paths. All right. Celia, what's a Boolean question I can answer, a more general one? Okay, yeah, so we need something slightly more specific than that. If you would like to go over Booleans, boom, there it is. We've got a video that already does that. So these days, now that we're in this online world where lectures have been cancelled, and this is really just a textbook discussion, we're wanting to try to minimize repeating. There's too many places to go looking for things. If it's in the textbook, I don't want to create yet another place where it's kept, because then when someone asks the question of where to go looking to learn this, there's two answers instead of one, or three answers instead of one. So if it's something more specific, then I can answer that. But here we go. Daniel does a great job of explaining these things. I was looking through his videos again last night, and I'm like, yeah, he's good. What is the question from Sam Zero? Yeah, I don't think we've answered that one before. Forums. Hit the Comp 1000 forums. If you've got anything about the assignment, anything about the way the course is running, hit the Comp 1000 forums. We're here discussing this page from the textbook. All right. Let's look at some nested Booleans then, because I think things get interesting when we nest Booleans. I was also going to do the debugging on the bouncing one, but I'm not 100% sure I can make that fail at will. I might have to make sure, I might have to prepare that one. Should I try and break that one now? Yeah. So these guys here are all Booleans, right? Yep. All right, so key pressed is a Boolean variable. I can make my own Boolean variable that stored the same value. Right? And that's a slot in memory. But that's what I have here is an exact copy of what's stored in this variable if I actually ran it properly. Always, whatever goes in this section of the condition is a Boolean expression. It might be just a single variable. It might be an ampersand, like an and or an or, so that it evaluates down to a Boolean. it might be a greater than or less than, so that it evaluates down. Maybe I'll try and do that. So you gotta realize that key pressed variable is already there in the system. It's a Boolean variable. So Boolean variables are always true or false. Okay, guys, try not to use the chat for stuff about Comp 1000 admin. That's not helpful here. We'll deal with that on the forums for Comp 1000. All right, so we're going to do one where the Boolean in here is slightly more complicated. So I can just spit out, so you can see it, key pressed on the console. So we can see always that key pressed is false, and then I hold down key and now it's true. And you can see now that the branching, remember I said they're mutually exclusive, so it gives me less options. You can see exactly what that's causing now. It's causing, when I lift the key up, for things not to go back, and as soon as I hit the key, the mouse doesn't come into it anymore, because it knows once it's hit this branch, it won't follow either of these other two either. So that's the less useful version, because there's only 3 cases. So we really wanted no stroke, if I recall. So now I've got back to my version where it's moving up and down. Good, and the key press doesn't interact with the moving up and down because they're on separate paths in the program so that both can run at the same time. So the last thing I'm going to do is say I'm going to draw it as a square when it's at the, let's say we'll draw, I need something that's a combined Boolean to show off the Booleans a bit better. Let's say we're going to draw it as a circle when it's high on the screen and a square when it's low on the screen. So now we need to get another path. One path for when it's a circle and one path for when it's a square. But how do we choose between them? And I'll just move to rec mode center to make it line up. I think that makes it line up. I don't normally like to change rec modes, but otherwise it'll look funny. So these are the 2 paths I want to choose between, line 30 versus line 32, 33. So if I'm choosing between them, I need an if, but what's determining where it's going to be? We know that what has to go in those parentheses is a Boolean. It has to come out to be true or false. So we could use a Boolean variable that we've got somewhere, but there aren't any more useful ones to play with. Or we could calculate a Boolean from some other variables. So this is what I'm going to do here. I'm going to calculate a Boolean from some other variables. And one variable I've got is the x, which is telling me how high I am up on the screen. And I can turn an integer into a Boolean by comparing it to another integer. So, I don't know, y is the one I want for up and down the screen. Let's just pick the number 400. If y is less than 400, this is integer less than integer, then that calculates out to be a Boolean, true or false. So now the parentheses has a true or false in it, which is what we need for an if to work. And hopefully when I run that, I'll see that whenever it's up high, I'm getting a circle, and hopefully as soon as it goes too low, it switches to a rectangle. So there's 2 different paths are now working, and because I did them as if-else's instead of all the others, it's all the options are possible to run. So now I've got so many different types of things that could be running. I could be running the one that's going up the screen, down the screen, with the border, without the border, circle or rectangle, lots of different paths. But it's easy for me to understand which path is running because I've connected it to things I can see. So this here is calculating down to a Boolean expression, but it's not so the different things we've put inside the condition now are a single Boolean variable that was built in for us, a single Boolean variable that was built in for us, and a Boolean we calculated from 2 numbers, and less than always calculates a Boolean. So can we make this slightly more interesting? I think so. I want to do a compound expression here. Right? Who can think of a compound expression that I might want to do? Well, the question from Nafael, how could you make it so it's a square and also moves left and to the right rather than up and down? I could answer that now, but I'm not sure it's super useful just to do that on the spot. That's exactly the kind of thing that will help you learn how it works if you experiment yourself to try and come up with that one. And when you're doing that, you should stop, think, think about the different branches that need to run in your program for that to happen, so that you can think about which if statements or which conditions, sorry, you're going to need to put things in. I'm just trying to think of something that I can do that's an AND. Well, let's do an OR. So what we're going to do here is we're going to say, I want you to draw an ellipse as long as it's high, but after a little while, I just want you to switch to always doing an ellipse. So there's still the same number of paths in my program because I've still got the path that tells me whether I'm drawing a stroke or not. I've still got the path that tells me whether I'm going up or down or not. And I've still got the path that tells me whether I'm drawing an ellipse or a rectangle. But instead of, I'm just changing the condition that's helping me decide whether to draw an ellipse or not. Before I said I'll draw an ellipse whenever the y is greater than or less than 400. Now I'm saying I'll draw an ellipse whenever the y is less than 400, or it's just been a while and I want to switch to ellipse forever. And how can I work out whether it's been a while? Frame count is great for that. Okay, so I'll get rid of this bit for now and we'll just see just the frame count working by itself. So now I've got one that draws an ellipse, or draws a square anytime until the frame count hits 600, and then that expression here, frame count greater than 600, switches from calculating to false to calculating to true. And we'll see the animation change. So now I've just got my square, and it's going to stay a square. Repeating jokes from, and now it switches to ellipses, well, to circles. And it just stays that way. But I can combine those two, because I can make very complicated Boolean expressions. This is a slightly more complicated one. It says, you'll be true sometimes and false sometimes. That's all a Boolean ever is. True sometimes, false sometimes. But exactly when are you true and exactly when are you false is a little bit harder to calculate. So it's going to be true as long as, the way ORs work, it's going to be true as long as this one's true or this one's true. And this one's true whenever y is less than 400, and this one's true whenever frame count's greater than 600. So we get that situation where it's true whenever we're high on the screen, or we've drawn 600 frames. So it's still switching back and forth, but soon after 10 seconds, it's going to stop switching back and forth and just go with ellipse every time, because the second part of the OR has turned to true. And the whole thing's true. Okay, so are there any questions on that I might be able to answer? No, because we're not going to do stuff. So Cecilia just said I could go over the exams, but we're not doing that because that's Comp 1000 materials. This isn't a Comp 1000 lecture. If you want to know about Comp 1000 things, you do that in the discussion forums of Comp 1000. Here we're having a discussion about software technology because it's not officially a lecture. You can't be running lectures officially on Twitch. That's not accessible to everyone. But, yeah, go for it. But maybe not, just to stop people from asking. Can you refresh the frame rate? You can anytime in your program, yeah. If you just change the frame rate, it'll change, I think. Never tried it. Let's try it. So let's make it, whenever we switch to ellipse, the frame rate goes slow, and then when we switch to rectangle, we see the frame rate go high, or back to normal. Now this is an example, by the way, of just experimenting. 9 out of 10 of the questions you ask about processing, yeah, that's slow. Got to try and get it down now. You can find out yourself just by putting it into processing and seeing. There we go. Yep, so frame rate's changing on the fly. As soon as we jump back to an ellipse, it slows right down, and when we get it back to a square, it goes fast again. Nice, there you go. Answered that one. Okay, but we're not here to do general, just kind of processing stuff. We're here to do conditions. Still banging on about assignments. Nested booleans, nested conditions, sorry. You can nest conditions as much as you want. What we've done here is we've done conditions that are one after the other, but you can do a condition inside a condition, and that creates complicated paths as well. Different complicated paths. So I can't get a picture up right now. I didn't quite get that set up before we go. But no, I don't know what I need to do that. I'll try and do it with. So when we did this one, we had two paths that went out and back in, and then two paths went out and back in, and two paths went out and back in. So that gives us lots of choices because you can follow the left and then the right and then the right and then the left. But it's also possible to have paths that branch, and then inside each branch there are two more paths of their own that eventually join and eventually join. So those are nested booleans. It's somewhat harder to come up with an example where nested booleans are useful, or sorry, are obviously useful but very simple, because the conditions that cause you to put a nested boolean in tend to be fairly complicated conditions that we don't want to quite hit just yet. Okay, well, why don't I do a copy paste instead of all that typing again? And I don't need any of this because I'm doing something simpler this time. What I'm going to do this time is I'm going to go back to using, just going to draw a circle that always follows the mouse position. Easy. And because I've got these built-in variables mouse X and mouse Y, that I deleted all the interesting stuff. Because I've got these built-in variables that vary for me without me having to do anything, then this will not draw the same thing over and over time. Every time it'll draw something different every time, because mouse X and mouse Y will have something different inside them every time. And so yeah, we're drawing a different thing every time because as I move the mouse X and mouse Y are changing. So what I want to do now is I want to change the color of this depending on which quadrant it's in. Let's start off just by changing it based on left and right. So the fill was currently set to 255, but I'm going to change that. I'm going to make it, if the X is less than width on 2, then yeah, do white, that'll be good. But if, sorry, mouse X. But if the mouse has moved over to the right-hand side of the screen, please use a red fill instead. Not real, but fill. And dunk, good. So now we've got two different branches of the code running. One runs when we're over the left-hand side, one runs when we're over the right-hand side. But if I wanted to do it for different quadrants, well, if I'd done this way, let's say I wanted it to be white most of the time, but the rest of the time, blue. Then I'm not going to get what I want with 4 quadrants. I'm just going to get the Y one dominating the X one because it runs after it. So even if it picked these 2 branches, whichever of these branches it picked, then it goes back and does this condition again and resets them to white or whatever. So I'm not getting the quadrant behavior I want. I'm just not getting the combinations I want. I'm running the different common paths, but they're overriding each other because of the program I'm writing. This is one where we need nested conditions. So what I want to say is, if I'm in the top left, let's stick with right. Otherwise, we're going to pick lots of different colors. So inside the if here, I put this if. Nested inside. And so now this line here, line 9, only runs when both these conditions are true, because it has to get past this one and it has to get past this one to get into here. This one will run when the top one is true but the inside one is false. And this one will run, line 14 will run when the top one is false. So what does that look like? Okay, got white in the top right. As soon as I go over to the right-hand side, I'm getting red on the X because that's the else case on the X. And then, but when I've got the top one false and the top one true and the bottom one false, I'm getting the blue. But this last quadrant still isn't getting a separate color. So let's make it so the last quadrant gets a separate color. So over here in this else, we want to put another one of these. But we want, now I've got to remember, this is the case where the X is not true, so we're over on the right-hand side. If we're over on the right-hand side and the Y is true, I'm going to go with, this was blue, right? And for the last one, I'll go with green. No, that was... So we've got 4 paths now, I think. Yep. But I've messed up that blue should be a red. So we've got 4 paths now, and the conditions for choosing between the 4 paths are nested inside each other. So this one is one of those ones where it'll branch, and then in each branch, it branches again. And you can see that if you branch twice and then branch twice again, you get exactly 4 possibilities, which is what we're getting here. And then they all combine back again at the end. And the 4 possibilities are all kind of siblings. They're all next to each other, meaning definitely only one of those 4 gets run. So that's a bit like where we might run the if-else. We could do this with an if-else, but our conditions would get more complicated. Okay, so those were the 2 things I wanted to talk about today. I'll keep an eye on the chat now for a little bit and see if there's anything else I can cover that will be interesting to you guys that's related to this material, not about things in Comp 1000 administrative stuff. But that's the kind of thing we're going to do in these streams, okay? We're going to pick bits of the material that I think are interesting. It's all covered in the notes, but maybe not covered in exactly this way. Maybe it's an example, a new example we can look at. And we can chat to each other on the chat. You can ask me questions that I can try and answer during the streams. More interactive than the online videos are. But there won't be anything in here that's not in the online videos, already on the online text. So I appreciate you all coming along. It's nice to know that we can make this work, and that worked pretty well. So we'll definitely keep doing this. And according to my restream thing, which I guess you guys can see on the screen as well, it's almost everyone's on Twitch, a few people on YouTube, that's okay. But we'll definitely stick to connecting it to YouTube because it's the one that records it forever, or at least for long enough. That sounds like an assignment question, so not here. Any limit to nested conditions? No, you can go as deep as you want. But I don't think I've ever, no, it's a lie. I've seen code that's got nested conditions down to 7 or 8 levels, and it would make most programmers cringe, cry, and spend the next week trying to come up with a better way to program it. Because all those conditions piling on top of each other get really hard to keep track of. But there are times you just have to do it that way. If you don't want the ellipse to go at the edge, all right, so that's an interesting one. So I'm following it along with the mouse. right? So if we were going to do that, I've got 4 different branches for choosing the color, and that's nice. But I've still only got 1 line of code that's helping me choose the position of the circle. So if we don't want the circle to go at the edge, we'll need more than 1 way of picking the position, right? Because right now we pick the position just by looking up the mouse X and mouse Y. But if we want it to stay in the screen, then we have to have one version where it's always following the mouse X, mouse Y, and another one where it stops following the mouse X, mouse Y and just stays where it is. Correct? So I'd have to put a if around this part of the code, which is the part deciding where the ellipse gets drawn so that there are 2 paths. And on one of those paths, the ellipse just keeps following, don't know what the condition is yet, but on one of the paths, we just keep following the mouse. And on the other branch, stay still. But staying still is a little bit more complicated than that, because to stay still in between frames, we need to remember our position. And right now we're not remembering our position. Elias wants me to rerun a stream on repeat until next week as an alternative to YouTube. I can try whatever you want. This is all new to me. To stay still, we actually have to remember our position. So we would need 2 new variables for that. And we just have to adjust this so that we're actually drawing, we can draw the ellipse at X, Y every time, right? That's not a problem. So that can be outside the path. But we'll update those 2 variables only when we're in this branch. And when we're in this branch, we'll do nothing at all. So what's the condition on this one? Well, we want to run the branch where we keep following as long as we're not too close to one of the edges. And we can tell when we're too close to one of the edges with a nice combination Boolean. So over here where our mouse X has gotten too low, we want to stop. Where our mouse Y has gotten too low, we want to stop. And when it gets too big, we want to stop. And when it gets too big. So any of those times, we want to stop. So that logic makes me want to turn it the other way around. Anytime it's too low, I'd like to stop. All the other times, I'd like to go. So I'm going to swap these 2 around so that the stopping one is the one that's in my if condition. Because I find that easier to think about. Always you can swap your ifs around, but all right, so when am I too close to the edge? I'm too close to the edge when mouse X is less than, how big was that circle? 40, 70. I'm also too close to the edge whenever mouse X is greater than 730. Or I'm too close to the edge when mouse Y is less than 70. Or I'm too close to when mouse Y is greater than 730. So now we've got 2 branches here on the on this section, separate from what color we're picking, to do with what position we're picking, and one runs when one of those conditions is true, and the other one runs every other case. Here we go. So it's not going off the edge anymore now. It's just pausing until I get my mouse back into a useful position. And if I move my mouse fast, it can not go all the way to the edge because it doesn't update the mouse position all that often. But anyway, that's the answer. That's a nice example too, because we had to use a more complicated Boolean expression here. Remember, this just calculates down to a true or a false. Whatever goes in these parentheses has to just calculate down to a true or a false. So I saw a question up there, can you use conditions somewhere else that's not a Boolean? Yeah, we'll use conditions in loops coming up soon. I couldn't keep track while I was doing that example, so if there's any other questions people want me to cover before I disappear, put them up. Can I make the color change like a transition? I can. That requires a timer, which is more of a variables topic. Could be a fun variables video to do though. I got 730 for the mouse because the circle I'm drawing is 140 by 140, which means it's half of it is 70, and the width of the screen is 800, so 800 minus 70 is 730. So that's the position that my mouse is in when I get right here. My mouse is at position 730 right now, and I know that because the right-hand side of the screen is at 800, and I know that the circle is 140 wide, so it's 70 pixels from the center to the edge. Yeah. All right. Sam05, assuming your price is to get booted out the course. Off you go. If you want anything to change back to default, I'm not sure what that means. I'll tell you what we're going to do. We're going to wrap this one up now. I think an hour is a good time for these. And I'll schedule another one some other time, very likely 4 o'clock on a Friday afternoon. And keep posting questions. You can post to me personally any things you want me to cover in these streams. But otherwise, I'm going to thank everybody for coming along, and see you next time.